Welcome, everybody. I'm Dr. Bob Morris, Professor of Biology at Wheaton College in Massachusetts. Welcome to another episode of Science with Dr. Bob. I'm curious about the climate. We've talked about how the best evidence shows that the climate change we're experiencing right now is driven mostly by humans burning fossil fuels. We're adding greenhouse gases at a rate much faster than has ever occurred naturally, and adding those greenhouse gases to the atmosphere is trapping heat. It's throwing off that perfect mix of gases that we've had for so long and created the climate that we enjoy right now. More greenhouse gases, more trapped heat, and a warmer Earth driving global climate change. That's what the evidence shows. More severe storms and more droughts and fire seasons, that's what we're experiencing as a result of that climate change. So I wonder, where's all that heat going? Well, 3/4 of the Earth's surface is covered with water. It's a blue planet, and in this blue marble image generated by NASA scientists in 2001 and 2002, you can see that beautiful globe and the blue oceans that surround our Earth. I wonder about how our oceans are going to react to all that heat. Well, there's a couple of hidden effects of climate change you might not affect, and we have some experiments here to talk about those. Those effects have to do with how water reacts to these new conditions, to the added heat and to more carbon dioxide that we're adding to the atmosphere. Well, one reaction is that ice melts. Okay, so I have a little model of an Earth here with land-based ice. There's our ocean in the basin, and we have a continent here made of some other containers. That could imitate Greenland or Antarctica. And we have land-based ice here that, as it melts, adds water to the oceans and increases sea level. So sea levels rise because of melting water. When ice breaks off of those continental ice masses and enters the ocean, well, that's another way we get sea level rise. It's that land-based ice that is adding to the ocean depth as that water melts and as that land-based ice slides into the sea. Once it's in the ocean, it has already displaced its own mass of water, and sea level rise. It's not adding any more depth to sea level by melting in the ocean. Icebergs aren't the problem, it's the land-based ice. Well, the second reaction of water has to do with water's amazing ability to absorb heat. That 3/4 of the Earth's surface covered in water is actually absorbing most of the heat of global warming. And that is due to the amazing ability of water to absorb that heat and retain it, and we call that property heat capacity. So we're going to do a little demonstration on heat capacity here with a volumetric flask over a high-tech heating device, a candle. So I'm going to light that candle. I'm just going to let that experiment simmer. So the heat is actually going into that water now, and we can mark the volume of the water with this Sharpie marker right there. We'll just see how that does. One would hypothesize that all that heat is going through the glass, that some is being absorbed by the glass, but some is being absorbed by the water. So we'll come back to that in a moment. Do we really know that the heat is going into the water? Well, for that, let's try another experiment. We're going to need two objects that one includes water and one includes just air. Well, here's the object that includes just air. There's an air-filled balloon, and we need another that includes just water. So there's our water-filled balloon. And we can actually test whether the heat in a system is going into water more readily than it goes into other things. Well, so air has some heat capacity. And if we heat this system here, this balloon, with its air, not surprising, we see the balloon explode because most of the heat has gone into the latex of the rubber. Well, what if we do that with our water balloon? Now it's safely above the ocean here, so we can try that experiment now. And I'm just going to heat this. I'm just going to heat that balloon and heat that balloon and heat that balloon some more, and no popping. No popping yet because, in fact, the heat capacity of water is so high that we can just cook it and cook it and cook it, and it will not burst. Now, in fact, the water is absorbing all that heat. So the heat is going through the balloon into the water, and the balloon itself is fine. That's the remarkable thing about the heat capacity of water. And what is that? What happens to that water when it absorbs that heat? Well, in fact, one of the surprising effects of climate change is that as the heat enters the water, not only does the water melt, but water expands. Warm water is bigger water. And in fact, of the 3 inches of sea level rise in the last 25 years, half of that sea level rise is due to water expansion and not to water melting. Half of it is due to water melting, land-based ice melting into the sea, but half of it's actually due to just the fact that warm water is bigger water. Warm water swells. And here we've just gone a couple of minutes, and I'm going to mark that level of water on our volumetric flask. If we let it go for a couple more minutes, you can see we're far from boiling here, but we've already swollen that 100 milliliters of water, that's about a half a cup of water, by almost 1%. So that effect of water expansion raising sea levels is happening all over the world. In fact, one of the worst affected areas is right here off of New England. Because of the geography and the shape of George's Bank, we're getting faster sea level rise here in New England than happens in many other places of the earth. So in fact, sea levels are not rising steadily as we had expected. In fact, the rate of rise is actually accelerating. So one of those undesirable effects of global warming is sea level rise due to water melting and water expansion as it warms up. And we're doing that experiment right now on our planet, where we are adding an unnaturally high amount of greenhouse gas to the atmosphere, and we're not liking the results. So instead, let's try the experiment where we slow those greenhouse gases. We slow the greenhouse gas emissions and see if we can't slow down that rate of climate change and preserve the climate conditions that have sustained our planet for so long. So there's another episode of Science with Dr. Bob. Thanks for watching, and until next time, let's keep on experimenting.